Good morning, this is your Stat Sensei, Mr. Spensei, and this is going to be a warm-up intro into errors, and all we're going to do is run a couple of real quick hypothesis tests. All right, so a credit card company with more than 35,000 cardholders with current mean balances of 2,500 tried to increase card usage. Okay, so we have a population mean of 2,500. That's probably important. Um, Tried to increase by offering frequent flyer miles. The company gave free miles to a simple random sample of 36. All right. Sample size. And found the sample mean to be 2542. All right. So our X bar is 2542. That's our sample mean. And it has a population standard deviation of 109. So because it's a population standard deviation, we're working with a Z. And Z is going to be equal to X bar minus mu, the standard deviation of the population divided by the square root of n. All right. And it says test at an alpha equal to 109. Test at an alpha equal to 3% to determine if the card usage has increased. So that means we're looking for a greater than. All right. And we have an alpha level of 0.03. So let's keep going. So we want the probability that Z is greater than 2542, that's our X bar, minus our mean of 2,500 divided by 109 over the square root of 36. So we're going to real quickly go to stat test, Z test, and I need to enter that data. Mean, we said was 2,500. Our standard deviation is 109. Our X bar is 2542. Our sample size was 36, and we needed a greater than. Make sure that's highlighted. When we do that, we get a 2.311. So the probability that Z is greater than 2.3119 gives us a p-value of 0.0139. 0.0103. So p-value 0.0103, that's 4 places. So I'm going to make this 4 places. And 103 is clearly less than 300. So our decision is reject the null. All right, number 2, a nutritionist claims that the average loss for a new diet plan is 8 pounds. So that's our claim. So that must be our population mean with a standard deviation of 1.9. Okay, so we have a population standard deviation of 1.9. A random sample of 35 individuals from a population size of 2,500 who followed the diet plan showed an average weight loss of 8.7. So the group had an average weight loss of 8.7. So that's our sample mean. Here it says determine if the mean weight loss is greater. So this tells me I'm looking at this way. This is greater than. And since we're working with the standard deviation of the population, we're working with a Z. So Z equals X bar minus mu divided by the square root of n. And we need to calculate our Z statistic and our p-value. So here we go. Probability that Z is greater than 8.7 minus 8 over 1.9 divided by the square root of 35. So let's do that real quickly. Stat test, Z test, mean 8. Standard deviation is 1.9. X bar 8.7, population or sample size of 35. And once again, oops, not 36, 35. And once again, we need a greater than highlighted, which we have. We calculate, and we get the probability that Z is greater than 2.1796, and that gave us a p-value of 0.0146. 0.0146. All right, and they told us to test an alpha level of 1%. So this is 0.01, and we got a p-value of 0.0146. So let's make this the same length. And 146 is greater than 100. And when the p-value is greater, we fail to reject. All right. Third one. A pit crew claims that its mean pit stop time for 4 new tires and fuel during the Daytona 500 auto race is less than 13 seconds. All right. So we have a claim of 13 seconds, a random sample of 32. Pit stops has a sample mean of 12.9 and a standard deviation of 0.21. Now, well, that came from the sample, so this tells me I'm working with a t. So t equals x bar minus mu s divided by the square root of n. All right. And we want to see whether or not testing at an alpha level of 0.05, whether or not is less than 13 seconds. So that gives me my directions. We need a less than. So we want the probability that t is less than 12.9, my sample mean, minus my population claim of 13, divided by 0.21 over the square root of 32. So in this case, we need to go ahead and plug this in. So we're going to go to stat test because it's a t-test because we use the standard deviation of the sample. We press enter and we find out we need to start putting some information in. Our mean was 13. That's the claim, was 13. Our sample mean was 12.9. Our sample standard deviation was 0.21. And we had a sample size of 32. And we needed a less than because we need to be less than 13 seconds. And we end up getting negative 2.6937. So the probability that t is less than negative 2.6937 gives us a p-value of 0.0056. And if I make that 4 decimal places, 56 is definitely less than 500. And so I'm going to reject the null. All right. Appreciate you watching, and I hope to see you on the next one. Thank you.